Today we are going to talk about types of distributions of data. And a distribution of data is kind of looking at the group of data and seeing how it's spread apart, but also to see kind of how it's related to each other and does it have a specific shape. We're going to talk about also graphing and how you can kind of analyze the data when it is graphed in a specific form. And there's a couple different ways that we can graph. So the first way that we're going to graph is by creating a dot plot, and then the second way we're going to look at graphing is by making a box plot. We could also do a histogram of the data as well, just to kind of show you a couple of different shapes. But we're going to look at the first, we're going to talk about the couple of shapes of distributions, and you can see that there's four ways or four different shapes that we could have data spread out. And the first shape, we say our data is skewed right. And if the data is skewed right, it actually means that the smallest frequency is on the right side. And frequency is the amount of data. So just making a little sketch here, if this were my graph, most of the data would be here on the right or the left side, and the smallest amount, the shortest amount, would be on the left side. So if this was a curved graph, which we'll look at throughout the chapter, and then I would have most of the data points plotted to the left. So skewed right, the smallest amount of data is on the right side. So if I have skewed right, we can also have skewed left. And I bet you can figure out what that definition is. So the smallest frequency would be on the left. And again, making just a little graph here. So it's pretty much the opposite. We've got the short on the left and the larger amount on the right side. There are two other types that we can also talk about. The third one we can consider a mound. And a mound happens when our graph looks kind of symmetrical. We know what symmetrical means. If something has symmetry, the middle of the graph cuts it in half. You have the same on either side. So making a little sketch, trying to look like our graph is symmetrical. When a graph is symmetrical, usually the mean and the median are also the same. There's two middle values. The average, we usually consider the mean. The median is the middle number. They're about the same number when a graph is symmetrical. And then the last one we have is a uniform graph. So if something is uniform, the graph has pretty much each section or interval that's divided up is about the same. And again, frequency is the number of times an interval or a group of data occurs. So here, this is going to look more rectangular because all of the data is kind of be at that same height. So that's what would be a uniform graph or a distribution. So we're going to look at an example down below where we're going to make a dot plot. And then we're going to see if we can determine the shape of the dot plot. So we have a winning air hockey score tournament. So you're good at air hockey, you're in a tournament, or you go to Dave and Buster's and maybe they have a tournament there. Um, and these are the winning scores of the air hockey tournament. And it wants us to create a dot plot. Well, a dot plot literally is just little dots that line up vertically on top of each other. In the numbers that we have here, it looks like kind of finding the lowest number is 12 and it looks like the highest is 17. We're going to just organize those information, those numbers on the line below. So kind of pretend that it's a number line. Making little tick marks here going from 12 to 17 to represent the dots. I think I can spread mine apart a little more. So now that we have the graph labeled, we're going to make some dots. And you're just going to find the value that you're given, list it up above, and literally you're going to make some dots. So at 14, we're placing a little dot, or you could place an X if you'd rather make an X. And then just keep on going. So a second 15 would go above. Trying to keep them all about the same level for each one. So you should have 10 dots. I missed one, 15. There we go. So if I kind of draw a curve around this shape here, I know it goes down to the 14, but if I was drawing a general curve, it goes up to that 15 value and then goes sharply down. So if I was trying to just kind of trace or draw a general curve around the data. So if you look at this shape, kind of thinking about the definition, most of our data is on the left side of the graph. The smallest amount of data, the least amount of data is on the right, and there's just one data point at 17. So this graph would be skewed right. So underneath, it asks us to kind of go a step further. A second air hockey competition was completed. Add these scores to the original scores. Does it change the shape? So we're going to continue with our dot plot and adding a couple more scores. I noticed these go up to 22. I'm going to just extend my line so that we can fit up to 22. And then just continue to plot the graph, plot those points. So after you have the points plotted, does adding these scores to the original scores, does it change the shape? So look at your new shape, kind of think about what that new shape looks like. And does it change the shape? Well, yes, of course it's changing the shape because the values are added, kind of changing the height of some of the intervals that we have here. And what shape does it look like? I would say this now looks like a uniform graph or a mound graph, not uniform. When you think of a mound, think of the pitcher's mound on a baseball field. That's a nice mound to think about. So this does now change the shape, and now we have a mound graph. So those are two different types of distributions that you can have, and a dot plot is one way to look at them. Another thing that we're going to look at is a box and whisker plot, sometimes just called a box plot. We're going to talk about graphing a box plot and creating one, still dealing with data. So statistics is like analyzing data. And when we look at creating a box and whisker plot, the first thing we think about is something called the Big Five. And it says also known as a 5-number summary. So it's a way for us to kind of organize the data after you're given a large list. In the Big Five, we're going to find 5 values to help us create this box plot. And we're going to start with something called the lower extreme. So when you think of something that is a lower extreme, think of the word extreme. See if you can come up with a definition for a lower extreme. So lower extreme is the smallest data value. If I have the lower extreme, we are also going to have an upper extreme to match it. And of course, that's going to be the largest data value. So now we know we have the smallest and the largest that are going to become part of our graphs. I'm going to go in the middle at number 3. We are going to graph the middle value, which is the median. And then we have 2 more things on here. So we have something called a lower quartile. And then we have an upper quartile. So quartile, quarter, we're going to be dividing this graph into quarters, fourths. And the lower quartile is going to be the middle value of the lower half of data. So now I'm taking the lower half and I'm dividing that in half. So that's how we get those quartiles. So we know the median is the middle number, and then the upper quartile is going to be the middle of the upper half of the data. So if you hear the word quartile, think of quarters divided into fourths. Graphs can be arranged this way, dividing things into different sections, quadrants. So we divide a lot of things by fourths graphically. We have a couple of other questions down below that we're going to think about first before we start to graph one of these. And we have a word called the interquartile range. We're drawing a box plot. And if you think about a box plot, it's called a box and whisker plot. A box and whisker plot has a box. It has whiskers, literally. These little lines are called whiskers going off of the box. And then in the middle it has the median. And if I think about the interquartile range, So we have the lower extreme and the upper extreme. And then we have the lower quartile and the upper quartile. So the interquartile range is that box area. And it's actually the distance between those two numbers. So how spread apart are the numbers in the box? And the way we find that interquartile range is by taking the upper quartile minus the lower quartile. And we call the interquartile range, we usually call that the IQR. So essentially we're looking at the range of that box. What's the distance that the box is spreading across our values? And then the last thing it talks about is outliers. And we looked a little bit at an outlier in section 11.1 and 11.2, kind of seeing how an outlier can affect the data. And an outlier, if you think of the word out in it, statistically is a number that is way outside of the group of data. So generally your data values are grouped together. They're not too spread apart, but you have this number that's really outside of the data. Of course, there is a way to determine if you have outliers. So we're not just going to be like, oh, this one looks like it's way outside of our data values. There is a way to determine that, and this is statistics. So there's always going to be a way statistically to kind of analyze information. So we're going to have two numbers. We're going to see if a number or an outlier is too big, because we have data on either sides of the data. We have a low end and a high end. And then we're also going to determine if there's a number that's too small. So this is a way to decide if you have an outlier. So if the number is too big, if it's beyond this, then it would be an outlier. If the number is too small, if it's below this value, then we would have an outlier. So in order to figure out if the outlier is too big, we're going to take the upper quartile plus 1.5 times the IQR. So essentially we're going beyond the upper quartile by 1.5 times what the IQR is. If you have a number that lies outside of that value, then it's considered an outlier. For a value to be too small, we take the lower quartile and subtract 1.5 times the IQR. So again, this helps us decide if there is a number that is an outlier. Is there a number that's lower than this value that we'll be calculating? So do you have a number that is 1.5 times the IQR lower than the lower quartile or below the lower quartile? So we have an example to look at where we're going to make a box plot. And in order to make a box plot, we have to kind of think about organizing the data first. And we're going to try and find those big 5 values, because the big 5 values actually create the box plot. So kind of looking at this little example that I have drawn above. There are 5 different parts that are drawn up here that divide things into quarters. So 5 points will actually create quarters for a graph, sections for a graph. We're going to see if we can find that information. So down below, I have the height of the world's 10 tallest towers, and this is listed in feet. And we're going to see if we can make a box plot from the information that's given. And the first thing you need to do is see if you can organize the data from least to greatest, because everything is divided up kind of thinking about middle numbers, middle values. So just look at the information and try and organize it from least to greatest. That would be your first step. The neater you are with this, the easier it'll be when we start to find the big five. Make sure you're double checking your information here. One number out of order or one missed number totally changes our big five values. All right, so data should be organized from least to greatest. I crossed mine off as I was working just to make sure that I was getting all of the numbers. We can quickly see the lower extreme and the upper extreme, so you can list those numbers down below. Know that it's organized. And then to find the other three parts of the big five, we'll have to start kind of thinking about the median, where's the middle number, and then after you know that middle number, the lower quartile and the upper quartile. So thinking about finding the middle number here, kind of working through your data, getting the middle value. So I have two numbers that would help create the median, and we're looking at 162 and or 1362 and 1369. So that would help us find the median. So 1362, 1369. We want the middle number. What's the center value? I'm going to create a little bar going down the middle to represent the median of my data. And then after you have that, we're going to then find the median of the lower half and the median of the upper half. So see if you can kind of list that information. Now that I have that median listed, try and find the lower quartile and the upper quartile. So I gave you a minute or two. I wanted to see if you could fill out the information. So right now down here we have the median, 1365.5. So that's the middle number. Remember, when you have two numbers, to get the median, we take those two numbers and cut them in half. So I placed a line down the middle of my graph. Now I'm looking at the lower quartile. Well, the lower quartile is going to be the middle of that lower half of values, the lower half of data. And if I want to find the middle of the lower half, I now have 5 data values that my median has divided it into, and I need the middle of that. Well, it looks like 1214. The upper quartile is the middle or the median of the upper values. And again, I now have 5 numbers. I'm finding the middle of those 5, and that's 1535. So if I ended up only having 4 numbers, I would have to take the middle 2 and divide them in half. So you're always finding the median. Think of the process of getting the median. The IQR, we said that was the interquartile range. So if you take your quartiles, 1535 and 1214, remember a range is finding the spread of the numbers. So you're subtracting those two numbers. And that gives us the interquartile range. So that spread of numbers for the interquartile range would be 321. So that means when we make this box, from the first part of the box to the end of the box, that spread should be 321, the distance between the two. And then the last thing we're going to look at to see, is there an outlier in this group of data? And to do that, we're going to use the little formula above, the two little formulas above. So isn't there an outlier, or are there outliers? There could be more than one. And we're going to see if we can find that. So to find the outlier, we have to find two values to determine if there's a number too big or too small. So these kind of act as like boundaries for us. So we take the upper extreme, or I'm sorry, the upper quartile plus 1.5 times the IQR. Plug that in your calculator. And we have 2016.5. So now that isn't my outlier. That's the boundary number. If I have a number that's beyond that, then it's considered an outlier. So if you look at your group of data, is there a number that is above, beyond 2016.5? And there is not. So I'm just going to put a little no next to it. There's not an outlier beyond this 2016.5. So there's not an outlier that's too big. Let's see if we can figure out if there's an outlier that's too small. So the lower quartile minus 1.5 IQR. So the low quartile, 1214 minus 1.5 times 321. Again, plug that in your calculator. And I have 732.5. So look at the data. Our lower extreme was 1149. So there is not a number below 732.5 if the smallest number is 1139. So are there any outliers? No, there are not any outliers. So in order to determine that, we have to get these two boundaries. So those are the two numbers that the group should be in. And if it is in those values, then there's not an outlier. But if you have a number beyond that, then we do have an outlier. So the last thing that we have to do is graph this. And there is a number line that's drawn for you. And because the numbers are spread so far apart, we probably need to kind of count by something different. Maybe counting by 50s would work. You kind of get to decide how to count here when you're organizing your data. I'm just going to start at 1100. Counting by 100s would probably be too big. We don't want to have the numbers too spread apart. You could probably count by 25s if you wanted to as well. Your numbers would just have to be, your little tick marks would have to be a little closer together. And make sure that you are going a little below and a little above our lower and upper extremes. So I started at 1100, I'm ending at 1850, just counting by 50s. And then our next part is to make a graph. And you can make this graph above or below your number line. We're not going to make it on the number line. So if you want to make it below, you can. If you want to make it above, you can. I think I have room to go above. My numbers are written below. So we're going to put a point at the big five values. I'm just going to plot a point above my number line. So plot a point for each of them where they would be approximately. Kind of on the same horizontal line. You're not graphing the IQR because the IQR should be the distance between the lower extreme and the upper extreme. So these will be the big five values. Now we need to make the box. The box is the lower quartile to the upper quartile. Well, our lower quartile is the second point. The upper quartile is the fourth point. So the box is that interquartile range. So those two values create our box and the distance between them. So we're going to make a box connecting those two values. Notice I kind of just made two vertical lines through those points. Now I have my box part, that's the interquartile range. And then you have your whiskers, and the whiskers connect the box to the lower extreme or the upper extreme. And then in the middle we have that median value, and the median is the middle, and we just place a line through that to represent the median. So now you have a box plot. So we found the big five, those 5 key numbers, 5-number summary. We found the interquartile range, that gives us the distance of the box, and then we determined if there was an outlier, and in this case there was not. If there did happen to be an outlier, so let's say that I did have a number that was less than 732. So we'll just say, just for sake here, so you kind of know what to look at, maybe I had a number that was 730. That would be my new lower extreme, and at the number 730, I would place a little asterisk. And that asterisk lets somebody know who's looking at it and analyzing the information that that is an extreme value. It's an outlier. So it's way below the information that we have. I don't connect to that. I would then connect to the second number that your second lowest value, or the first number that falls within your group of data. So if I had the number 730, I would put a little asterisk. I would still graph the lower extreme at 1149. That's not an outlier. And I would connect my whisker to that lower extreme value. That would not be an outlier. So an outlier is beyond, way beyond the two boundary values that we have. So you have a worksheet that is posted right after this video, and the worksheet is graphing box and whisker plots. One of them will have an outlier, so make sure you're checking for the outliers. Try and make that graph as neat as you can. If you want to graph it on separate paper, you can, but I did try and provide some space for you to make a graph. Have a great day. If you have questions, send me an email.